watching this video. This is Olenjolai Singo. I'm a teacher of chemistry, advanced chemistry. I'll be teaching advanced chemistry. I used also to teach many subjects. Don't get confused about me. That's how God has designed me. Because sometimes you say that, how comes that you have been teaching me physics, mathematics, engineering mathematics, basics physics, and so forth. Okay, that's what I came for. Okay, so I would like to welcome you into this YouTube channel and into this video. It's actual that I'm going to teach you about advanced chemistry, which is interesting. It's a little bit challenging because it advances a lot of concepts, but it's very interesting. It is beautiful. That's what just I can tell you. So I don't have a lot of words to convince to give you a promise, but just a few informations which are relevant for you who is watching this video, or even relevant to somebody that you want to share with in this video. Okay, this is lecture 1 today, which we are going to start for advanced chemistry. You will be in these sessions, in this channel, you'll be learning a lot of videos in physics, in advanced physics, advanced chemistry, advanced mathematics, basic applied mathematics. You'll be getting them, all of them in this channel, right? So that's what I want just to insist you all, even if it's not in this channel, but in another related channel. I used to teach all of those subjects. So I don't want to waste much of your time. I want just to give you a few informations, and then we go to the lecture, to the business that you have been waiting, and even myself I've been waiting for a long time, because I did a lot of preparations on this lecture in order to come and teach you and answer many questions that you have, and even omitting the fear that you have in advanced chemistry. From the beginnings to the end of this lecture, and even of this program, digital program, actually that I want to tell you that you like chemistry and you love chemistry. Okay, number 1. Myself, I am a Tanzanian. I studied in Tanzanian curriculums and even some other African countries. That's not the case. The issue is this: you like chemistry, you have to study chemistry in order to pursue your vision, right? That is good, and I congratulate you for that choice. But advanced chemistry is broad. It has a lot of things to cover. So to narrow, in each country they used to design something we call it the educational system. That educational systems actually break down the ideas according to the demand of the nation, and then come up with a syllabus. So the syllabus of United Republic of Tanzania is not like the syllabus of maybe in United Kingdom. It might be have a little difference because the problems existing in United Kingdoms are not similar to the problems that exist in United Republic of Tanzania. So to be focused and to actually to make their concept is relevant for particular people, but these materials will be used worldwide and are very essential. So just sometimes if you are not non-Tanzanian, you can even skip this part, because actually it might be even giving you actually this discouragement. I don't discourage you, I encourage you, but just I want to give them detail. So for them to be sure, for the Tanzanians to be sure that about what am I going to do. So number 1, one of the equipment or one of the material or one of the weapons that you need in advanced chemistry is the syllabus, right? So this is the syllabus of United Republic of Tanzania. So United Republic of Tanzania, Ministry of Education and Vocational Training, chemistry syllabus for advanced secondary, Form 5 to Form 6. So what is happening actually? Mean that by using this syllabus, actually give us focus, what we have to cover, what the contents. The syllabus describe a lot of information. For example, that in one of the columns just describing the topic or subtopics. Another column describing the specific objective on that particular topic or subtopic. Then teaching and learning strategies. Then the syllabus explain about the teaching and learning resources. This syllabus again explain about assessment. Then estimated number 40 of periods, right? So I ask you and I insist you as a good student, make sure that you get this syllabus. If you're wondering yourself where you can get this is syllabus for the student, and every student I advise him or her to make sure that you have it, whether you are doing private study, you are at government school, private school, regardless that you where are you, by the way, you need this syllabus. Because even myself, I need this syllabus in order to have a particular focus, right? So if you need this one, go to the descriptions of this video. You will see the way that you can order this book, and then so you can do the mobile transactions or banking transactions in order to get this book. So this is the one of the reference. Advanced chemistry, for according to the Tanzanian syllabus, it comprises 7 chapters. So you have to study 7 chapters for your 7 topics. 7 main topics for Form 5 and Form 6. I'm not going to teach you all the 7 topics today. I'm just going to start the first chapter. But I gave you a promise. Stay connected, subscribe with this channel, like this video, and also make sure that you share with your colleagues, and then you prepare the number of questions that you can ask in the comment sections of this video, even other videos. So get connected, you'll be informed. I'll be uploading, so adding videos day after day or week after week. So stay tuned. We'll enjoy at the end of the lesson. Okay? So that is one of the weapons that you need. The second weapon is you need textbooks. Okay? And is this very important introduction because it's the first topic. I'm introducing the subject of advanced chemistry. Remember that this introduction is very important because to give us a focus, it gives us just like the route that we have to follow in order to achieve the main objective. Okay, so I have listed some of the books that can assist you in chemistry, and even your schools that ask you to have those books. It doesn't mean that you should have all of them, but at least you should have 3 to 4. Also, I used to sell these books in case you need them. You can order, or you can go to the description of this video. You'll see how I can ship them in the nations of Tanzania, in every regions of Tanzania, even in Zanzibar, right? So the first reference textbook, because you have textbook, that's the second thing, that's the second weapons that we need, textbooks, and also you have question and answers books. The first textbook is Conceptual Chemistry, Class 1 and Class and Class 1 and Class 2 by S. Chandi. Okay. Then the second week is the second textbook, Inorganic Chemistry by Nkaiza, that explaining about inorganic. Advanced Inorganic Chemistry, Volume 1 and 2 by Chandi. Even General Chemistry by Nkaiza, Physical Chemistry by Nkaiza, Organic Chemistry Part A and B by Tanzanian Publishing or by Tanzanian Institute of Education. Then you need the book called the Physical Chemistry by S. Chan. We can write down. Then you need a book called the Advanced Chemistry, okay, Advanced Chemistry, published by the Cambridge Low Press Edition. Okay, then you need a book called the A-Level Chemistry, 4th editions, by Ramsden, so the outside is Ramsden, and also you need a book called the Practical Chemistry by Mlungu. And they can even refer some other textbooks which can assist you. But again, you need notes. Books are not enough. Books are just like a part of them. Those books are very important to have at least 3 of them. So why? Because these books, they explain, for example, you can find that maybe S. Chan is good in physical chemistry, but it's not good in organic chemistry. So you need organic, maybe in organic part A and part B, which explaining in details about organic chemistry. That's very important. That's one. That's 2. Okay. Then number 3, you need textbook where you can get the number of questions. These books also contain exercise at the end. You have to make sure that you try your level best, because it means that you will test yourself and you'll have a lot of practice before the final exam. Again, the third weapons which I would like to recommend for you is these review books or question problems and solutions books. So this is a review, Advanced Chemistry 1, because in Tanzania, for Advanced Chemistry, we have 3 papers, 3 final exams. Okay, 3 papers in final exam, or which we call the Advanced Certificate Secondary Education Examination. We have paper 1, Advanced Chemistry 1, Advanced Chemistry 2, Advanced Chemistry 3, which is practical. So this is for Chemistry 1, and this is for Chemistry 3, Chemistry 2, I'm sorry. So these books, they have, for example, this one, it has problems and solutions from 2001 up to 2016. Also, this one comprises questions from 2003 to 2018. I'm not going to copy the solution they did. I might even use a different approach, but it will give you a good time to practice and mark yourself and see whether you are right or you're not right. So these are good also for learning. Even myself, when I was in high school, I used this material effectively. Okay. So again, last but not least, I ask you now, this is the time that you have been waiting for a long time. I've been waiting myself for a long time, and even you have been waiting. So now it's a good time for you to take your exercise book, to take your pen, to take your pencil, take your ruler, to take your, and even just that you have it means that you have this video right now, and then be in a conducive environment, and make sure that you set your mindset. I need your clear mindset. Now it's a time that now we are going to start the business which make I and you to meet today. So get connected. You should also have a scientific calculator. This is the first weapons, which is very important. Scientific calculator, for example, this is function 991 Casio, right? It's very important because we are going to do computation, and actually those computations, they include a lot of digits which you cannot do by using your brain, like when you've been in ordinary level. So remember, this material might be used by students, by college students, high school students. Anybody in the world can use these materials because we have kind of the synonyms in case of the science. So the subject is advanced chemistry. When you say advanced chemistry, actually it means we build it from the basic chemistry of O level. We build these foundations from the basic chemistry of O level. The main topic, okay, the main topic, advanced chemistry, as I told you, it has 7 chapters. I will make a video to give you the introduction concern about that. Of the day is physical chemistry. Physical chemistry has 5 topics, not subtopics. And the topic of the day, the main topic of that, means the topic of the, we have physical chemistry, I'm sorry, excuse me. The main topic of the day is called the physical chemistry. It's called the general chemistry. General chemistry. Say with me. General chemistry. General chemistry. General chemistry. Let me write it clear because this is a very important point for you. We call the main topic general chemistry. And then the topic of the day, we call it the atom. And the topic of the day. Okay? I will teach you in different lectures. This is lecture 1. According to the Tanzanian syllabus, okay, so I said that according to Tanzanian syllabus, okay, we said that the topic of chemistry, the topic of general chemistry, has 2 topics in it. The first one, we call it the atom, which you are studying right now. The second one, we call it the chemical bond. Chemical bonding. Chemical bonding. So that's what you have. And this is the atomic structure, this is the chemical bonding. So you have those 2 main topics in case of general chemistry. So now, before I take you into the subject, let me share with you the contents of general chemistry. General chemistry, according to the syllabus. According to the syllabus of Tanzania. So, in the book of syllabus, state that chemistry, before also I go the further point, I want us to state something. The targeted student for this material, the first group are Form 5, who are pursuing advanced chemistry. Also, Form 5, who are expecting to go for the high school, for the Form 5. And these are already there in Form 5. Also for the Form 6, we want to review the materials, but also for the college students. when you say college, students who are studying what chemistry. For example, ordinary level students and even bachelor students. You can use this material for the quick review and even for comparisons of the concept. So, according to the syllabus, you say the subtopics of what? Of the atom. Subtopics of atom are this. Okay, the atom. Then we number them, so 1.1. The first subtopic is called the Dalton's theory. Dalton's atomic theory. Dalton's atomic theory. Second one, 1.2, is called the Bohr's atomic theory. Sorry. 1.3, after we cover that once, is called the atomic mass. Atomic mass. Then the fourth subtopic, 1.4, is called the quantum. The quantum theory. Quantum theory. So the topic of the atom, or the atomic structure, called the atoms or the atomic structure, consisting 4 subtopics. The first one called the Dalton's atomic theory, Bohr's atomic theory, the third is atomic mass, and the fourth the quantum theory. So if you cover those according to the Tanzanian syllabus, then you are ready to be tested for the final exam, and even you are ready to solve problems concerning about general chemistry. So that is according to the syllabus. So today, I'll be teaching you this part as the first lecture because you are familiar. It's actually closely related to what you know. I have decided myself when I've been reviewing, I've decided to start with this part because you know about atomic number, you know something about atomic mass, isotopes are familiar. Rather than if I start with Dalton's atomic theory, which is a little bit advanced, and even Bohr's atomic or the quantum theory, I will come later to those parts, right? So now, if I take the subtopic of the atomic mass, okay, atomic mass, then the syllabus gives you specific objectives. Give us a section, so I call them specific objectives, which is state like this. By the end, of this subatomic or subtopic, the student should be able to explain the subatomic particle atomic particles, B, compare mass number with atomic number. Atomic number. C, discover describe the mass spectroscope. So those are the objectives that we have to achieve when we say that we have finished the said part of 40, the said part of the atomic mass, or the said subtopic of the atomic structure, which is called atomic mass. First, the students should explain the subatomic particles, and this one, I know that you covered it well during your O-level studies. Unless if you have some troubles, let me know in the comment section. Compare mass numbers with atomic numbers. I believe that you did it very well in your O-level. So something new is descriptions of mass sorting spectroscope. In some of the schools, after that which they used to go deeper, maybe you can find even the students or even some of you have idea about the mass spectroscope. But actually this is the very interesting point that we have to start with. Right? So are you ready for that? One point I want to make before even we go to the beginnings of this lecture one, or before we continue this lecture one, is this one. Myself as Olenjolai, I don't know everything about advanced chemistry. I just know a little, but I'm ready to transfer that knowledge to you. So join with me. So the subtopic, the subtopic of the day is called the mass. What am I going to teach you is mass spectroscope. This is the contents of lecture 1 and lecture 2. Okay, because in lecture 1 I will teach you the concepts and even the drawings of this mass spectroscope, and then lecture 2 will do the competition. Or we'll be solving problems. In some of the books we call it mass spectrometry. Mass spectrometry. Some of the devices we call it mass spectrometry. Say it, mass spectrometry or mass spectroscope. So we have now. So let us start the session. So the first question we have to ask ourselves: what is mass? What is mass spectroscope or spectrometry? What is mass spectrometry? That's the first question. So according to the finding, mass, this is capital, mass spectrometry, we say that is the analytical laboratory, right? Is analytical laboratory technique, analytical laboratory technique used to identify composition of a substance, composition of the substance by their mass. Mass. These are the definitions of mass spectrometry. Say it again. Mass spectroscopy or mass spectrometry. Don't feel shy. Pronounce these words. They are very important in your life. Mass spectrometry is an analytical laboratory. That's the first keyword. Analytical laboratory technique used to do what? To identify what? Composition of what? Substance by what? By their masses. So use mass to determine the composition of the substance. How? Stay connected. Stay tuned. I will tell you how. So that's the first terminology. And this part is just the introductions, but that's the first terminology that we have to learn. The second terminology, this is number one. Just number two. The second terminology, which is very important, we call it mass spectrometer. Mass spectrometer. Say with me. Mass spectrometer. Say it again. Mass spectrometer. Say it with passion. Mass spectrometer. What is this? Mass spectrometry. What is this? Mass spectrometer. There are two different words. So, the second question that we have to ask ourselves is this: what is mass spectrometer? What is mass spectrometer? Mass spectrometer. Mass spectrometer is an instrument. Is an instrument. This was not an instrument. This is the technique. This is the technique. This is an instrument. Okay, which can measure primary, which can measure them. So this is an instrument which can measure the masses. With this instrument, we can measure the masses of the atom, and also we can measure the relative concentration of what? Of atoms and molecules. Is it interesting? You can find some other definitions or different ways of defining the mass spectrometer, but these are some of them, right? Or this is the one which is very important. And when we say that this mass spectrometer, the mass spectrometer is used to determine the atomic mass, okay, the atomic mass, and to detect presence, detect the presence of isotopes. Interesting. You used to study isotopes, but you didn't know how to detect it, or how the chemists find them, how the chemists maybe determine that maybe the isotopes of carbons, okay, abundance, or isotopes of chlorine. How did they know? So now in general chemistry, I will teach you step to step, and then you'll find how we used to say that chlorine has 3 isotopes, right? Maybe chlorine has 3 isotopes. Carbon has 2 isotopes, carbon 14, carbon 12, etc., etc. So you'll be learning step by step. So stay tuned. The spectrometer, or the mass spectrometer, got here. The mass spectrometer, because this is specified at which spectrometer, is used to determine the atomic mass, number 1. So determines the atomic mass, this is number 1. And also to detect the presence of isotopes, this is number 2 application. And then the abundance. And abundance means percentage, their composition, this is number 3. Right? Very interesting. So it means that number 1 used to determine certain atomic mass. Number 2 used also determines the presence detect the presence of what? Presence of isotopes. And then number 3 used also determines what? Abundance. Abundance of what? Of the atom or molecule. Interesting. soon you are approaching to be a king of mass spectrometer or a king or a queen mass spectrometer. And I believe that you'll be solving problems of mass spectrometer in a different way. So again we say that this in chemistry, in order for a chemistry to understand the concept of mass spectrometer, then he has to study the following parts, following 6 parts. Right? The first part you have to study, we call it ionization. Ionization. The second one, or the first ionization, but the second one we call it vaporization. This we call it ionization, and the ionization and vaporization. However, the process of vaporization has to start. Okay, so 5, there are only 5 parts important. Number 2, you have also, I have to teach you about acceleration of the atom in the mass spectrometer. The third part, also I have to teach you about the part known as deflection. The fourth part, which I have to teach you, we call it detection. Now we detect the atoms, the isotopes, detection. And then the fifth part, we call it the recording. And the 6th part, recording. So these words must be memorized in the sequence. So these parts are listed in the sequence from the first part to the last part of mass spectrometer. Is it interesting? Yes. So then now, the next part of mass spectroscopic or spectroscope, I want now to draw a diagram of 14 of mass spectrometer. So we say that to understand the principle used by the spectrometer, to perform its activities or its measurement of mass abundances and the detection of what? Of isotopes. Then a diagram of mass spectrometer must be used. So for you to understand how the principle of working of mass spectrometer is not enough. It's tough, first of all, to learn by reading those descriptions or those explanations. The best way, we have to draw a diagram of mass spectrometer, and then we explain its principle and how does it work. Okay? So join me in the sketch of this mass spectrometer. I'll be trying myself, but you can even look online. You can use the references online or in different sources to see even in color. For me, just a big draw by using the black and white. For you, can even refer the colored spectrometer. Okay. You can also go to your school lab and ask your teacher to show you the mass spectrometer. It's your right. Okay? So again, here we have a plate, and here again we have another plate. Here we have this is accelerating part. Okay? We'll explain what does it mean. And then from this point, we have a very important part which we call the deflection region. So here we have a heating filament. Filament. And then this point, you have vacuum pump, the spectrometry routine at this point. Then we have again another part here. Then we have the output at this point. It goes to another section. And then the output of this section, and this one we call the amplifier. This goes to another section. We call it the chart recorder. Very important part. This is the recording section. So this point, call it deflection. And then this one, called the vacuum pump. vacuum pump. This section, we can even shade. So it has a shadow. So this section, when you say this section, both this and this, we call that sections deflection. Deflection ring. But what does it do with this deflection? This is a magnet. And this section, this one, with this ray, we call it acceleration section. This is part 2, the second part that I have mentioned there, acceleration. And then this section, this point here, this one, this we call it ionization. Ionization chamber. Here we have another part we call it vaporize the sample. Vaporize the sample. Then this one we call it heat source, or source of heat. Source of heat. So that one's vaporize sample. Here's to vacuum. And then this is figure 1. We call it mass spectrometer. You can call it even figure 1.1 because we be having many figures. So figure 1.1. We have 1.2, 1.3, etc., etc. So my dear student, my beloved student, that is a diagram of what? Mass spectrometer in chemistry. Let's draw it on your hand. Don't take a photo. You have to use your own hands to draw it, like the way I drew it myself. I can use the digital technology. I could take even the photo and show you in place at in front of the camera, and then show that this is a mass spectrometer. Then you'll enjoy and you'll say that, thank you, Sir Olenjolai, but I didn't help you because you didn't see that how you can draw it yourself. So from now you don't have an excuse. If you'll be asked to draw it, you have to draw it. You're a chemist, so you have to like draw it. So this is the figure now of mass spectrometer. One, let me explain to you how does it work, and then we'll go to the details, explanations, or on learning those 5 parts. Okay? Listen carefully. This is the mass spectrometer. And this is the inner part of mass spectrometer, right? Physically, it doesn't mean that we'll find a device, mass spectrometer like this. This is the inner part, and especially that we used to learn the operation part, right? The chemical or the chemistry operation part. There are some other parts. It can be maybe electrical mass spectrometer or some other spectrometers, right? So what happens? This is the point of entrance. Here we have vaporized the sample. What the means of vaporization? Vaporization, we say that is what? Is a physical change? Why not? We say that liquid, or either that maybe you change solid to liquid, liquid to gas. So the destination is forming gas, right? So the sample, which you want to measure its mass, you want to determine the number of isotopes of that sample of the atom, and you want to determine its abundance. Is introduced at this entrance point. That's why we call this one vaporize the sample. Then the vaporized sample, as soon as it has been introduced in the mass spectrometer, it will reach the first sections or the first chamber called the ionization chamber. So in the ionization chamber, remember that this is an atom. What's going to happen here? And then a lot of things will happen, but in brief, in this ionization chamber, the vaporized sample is going to be given ionization energy If the sample has to lose 1 electrons, then it will be given the first ionization NH, as well as I will teach you in energetics or in chemochemistry. If the atom is going to lose, or it has is at a tendency of losing 3 electrons, right? Losing 3 electrons, or 2, for example, for aluminiums, then it will be given, at this point, it will be given sort first ionization energy, second ionization energy, and third ionization energy. But if the atom is just sodium, then we need only first ionization energy. If the atom is magnesium, which is period 2, period 3, which actually is 12 elements in the periodic table, then we have to give it the first ionization energy, second ionization energy. So that's the main function of this chamber. After the atom has been ionized, so now we don't have atom anymore, we have an ion. Say an ion. So not an ion, the one that we used to maybe we use in domestic. I don't mean about that. Ion, because sometimes pronunciation is a little bit challenged. I'm not talking about this ion. No, I'm talking about this ion, right? So we have an ion. So what happens? So this ion is still moving or traveling with a very low speed. So what happens? So in mass spectrometer, we need these ions to be accelerated, to move. It means to move with a very high speed. So what happens? So we as the chemists, we're against that we make another chamber known as acceleration chamber. So the main function of acceleration chamber is to accelerate an ion which has been ionized in ionization chamber, right? So when you accelerated, that ion now will reach to this point, to this part, which is called deflection point, and this we call the deflection field in some of the books. Okay? Called deflections, or we call it deflection field in some of the deflection field. So be familiar about that. Then when it reaches a deflection field, what's happening here? Remember that at this point now, because now it means that this sample has been vaporized at this point. So these dotted lines is the trajectory, say trajectory of 40 of this vaporized atom, and then at this point now we see the isotopes now of 40 of atom. Okay, so this now it has been moving linearly. So remember that this atom, it has been moving linearly in a straight line. So when it reaches in this radius of 40, you can even just add this magnetic field, you can extend it, okay, so that you can understand the concept, okay? So when it reaches at this point, what happens? This magnetic field, this magnet, so magnet 1, magnet 2, these are the magnets. So when it reaches at this point, then these magnets will start deflecting. Instead of, because remember here, if we consider the trajectories are the vector, this the vector, means this the directions of what of electrons. So it reaches here because this ion is actually is electric or is electrical ions. It will be deflected by this magnet. When it will be deflected now, remember that it is highly accelerated elements. Then it reaches at this point and then start forming isotopes. So for this element, for example, if you have first line, second line, third lines, it means there are 3 isotopes. So here it determines isotopes, it determines abundance, then it determines its atomic mass. So again, the journey continues, reach at this point at the vacuum pump, also it has something else to add on that, and then now the ions reaches to the deflection, so detection. Sorry, this is not deflection, make correction please. I wrote, could even ask me, this is detection unit, right? So correct it please. Yes, detection unit. So then here we detected the number of isotopes, we detect the abundance, we detected the mass of an atom, and then we'll see how does it operate, because we have computations, we have mathematical, and we have problems. And then the output of this sample, so this is still the output of detection region or detection unit will be sent to the amplifier. Say amplifier. Amplifier is very important part in analog electronics. I like electronics a lot. I'm an electronics engineer, that's what I can tell you. I used to learn a lot about amplifier, and they are doing a big business actually that in the world of electronics of today. So here it means that the ions will be amplified. Means that what the means of amplification? It means that changing its magnitude from the small magnitude to the large magnitude by using what the amplification factor, which we call gain. It might be current gains or voltage gain. And then here we have chatoti recorder. So this is the recording sections, because we say recording section, the last part. So here the point that we use to record, and here this is the point where we used to find out a display which will be showing the lines of the isotopes which will lens in near future. And then that's how now we have that's how the mass spectrometer measure, or that's how the mass spectrometer operate. Okay? So in the next few minutes I will be explaining this part, how does it work, this part, and even this part. So I've just given you an introduction. I'll be explaining and writing some sentences for you to review them. So after we've discussed it, this, remember that one thing that I want to tell you, and even myself I find when I was in high school 11 years ago or 12 years ago, this is the common question for the midterm test for those pre-form 5, and even the final exam in some of the years I used to give you 10 marks to draw this and explain how does it work. So take care about this. You might remember me maybe one day within a specific time when you are in hot chamber of exam. Then another part that we have to cover, we want to learn in brief principles of mass spectrometer. Principles of mass spectrometer. What are the principles of mass spectrometer? There are 5 principles. So the question is, this is maybe question 3. Yeah. Describe briefly 5 principles of mass spectrometer. The first principle is this. We say that the substance, it means atom, not the ion, the substance to be analyzed. Substance to be analyzed is firstly vaporized. It's firstly vaporized, right? And it is then it is introduced in the ionization chamber. The ionization chamber, where a metal filament is heated strongly to produce enough energy. To cause ionization. Cause ionization to occur. occur, that is positive ions, are formed. The first principle states that the substance, for example, magnesium, aluminium, sodium, lithium, right, carbon, the substance to be analyzed, that we want to analyze, we want to measure its atomic mass, we want to detect the number of isotopes, we want against to know its abundance, is first vaporized. What the means of vaporization, as I told you, if it is in solid state, vaporization reactions with the given atomization energy will be given to that metal, and then will be changed from the solid state to the gaseous state. So what we used to introduce the mass spectrometer should be in gaseous state. Remember that. And then it is introduced into the ionization chamber. So this is the ionization chamber, as I told you, ionization chamber. So then where a metal filament, so this is very important again, a metal filament, where the metal filament, this one, this is metal filament. A metal filament is heated strongly. So this metal filament is heated strongly. So we have a filament here. Okay, we have a filament. So metal filament is this one. Is heated strongly, right? It's heated strongly. Metal filament is heated strongly. Metal filament is heated strongly to produce what? Enough energy to cause what? Ionization to occur, and that is the positive ions are formed. So we used to form positive what? Ions. Means electrons. Ionization means that it is a process whereby an electrons, or whereby 1 mole of an atom is what? 1 mole of an atom is losing 1 electrons to form what? 1 mole of what? Mono positive ion, if it's first ionization energy. But from 1 atom of what? 1 atom of positive ion. No, 1 mole of positive ion. By means of what? Ionization energy. The second principle is this. The positive ion ions produced in the ionization chamber. Ionization chamber are accelerated now by the negatively charged particle, negatively charged plates. So the positive ions produced in the ionization chamber accelerated by the negatively charged plates. Where are the negative charged plates? This one. Okay? So these are the negatively, so this is negatively charged. So this is negative, negative, negative. This is also negative, negative, negative. Charged what? Particles. Okay. So the third principle, we said that the positive ions produced then deflected. So we say about accelerated, it's better if you bold it. So let us bold this way the acceleration or accelerated. So here are deflected. 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 Okay? Are deflected by the magnetic field. By the magnetic field, according to the so remember that these are the principles of working. Principles of working of mass spectrometer. You see it? Let me illustrate it clearly. That's very important to read. This is how the mass spectrometer works. Principles of working of mass spectrometer. So describe briefly 5 principles of working. 5 working principles. 5 working principles of mass spectrometer. Or sometimes in some of the books, how, you can ask you a question, how does mass spectrometer work? Explain how does mass spectrometer work. So this is the description. So the positive ions from the acceleration chamber produced are then deflected. By the magnetic field. By the magnetic field, according to the mass. These deflections depends on what according to the mass. Okay, mass to charge ratio. Mass to charge ratio. Mass to charge ratio means mass over Z. Such that ions with greater value of ratio are deflected less. I don't want to rub here. Please make sure that you copy that section. I want to leave this because I want to use it for explanation. But let me just explain this the principle. The positive ions from what? Acceleration chamber, where we have negative plates, are deflected by the magnetic field. Here, this is the positive ions deflected by the magnetic field, according to their mass to charge ratio. Mass to charge ratio. So this is the point where it has the mass to charge ratio. So listen, what happened? An isotope which will have a large ratio of mass to charge ratio will be less deflected, right? principle which I've explained here, that the substance to be analyzed is first vaporized and it is introduced in the ionization chamber, where a metal filament is heated strongly to produce enough energy to cause ionizations to occur, that is, positive ions are formed. It is the place where the ionization process is taking place. And the second principle, that is, the positive ions produced are accelerated by the negative charged plates. So it means that these are the negative plates, these three are negative plates, which are used to accelerate produce the ions in the first chamber or in the ionization chamber. And then the third principle states that the positive ions produced are then deflected by the magnetic field according to the mass to the charge ratio. This is the point. This is the chamber that the third principle is explaining. These are the magnets, at the above magnets, and we call it deflection chamber or deflection regions, whereby the ions now it has been ionized in these high speedy ions that moving or being accelerated by this negatively charged plates. Okay, so in this deflection chamber, what happens actually? We have different. Remember that some of the elements contains isotopes. So what happens at this point? So at this point, we say that according to the mass to the charge ratio, it means that the ions which will have a less mass, it means that less mass to charge ratio, and then still be highly deflected, while the ions which have the greater mass to the charge ratio will be less deflected, and the one that have intermediate between the highest or between the largest and the smallest tend to be medium deflected, as it has been shown here. So let me take you to the first principle. Before we go to the first principle, I want just to explain you in details about the second principle. Okay, the second principle. So in the second principle, you say that ions that will have a high mass to the charge ratio will be less deflected, while ions which are less mass to the charge ratio will be highly deflected. So let us write that sentence. So we say that the ions, say with me, the ions, okay, the ions with greater value of the ratio of mass to charge ratio, in bracket mass over charge, okay, are deflected less. While ions with a smaller ratio are deflected more. While ions with less ratio, less or smaller ratio of the mass to charge, smaller ratio or with less ratio of mass to charge means, okay, will be deflected more. Okay, will be deflected more. So this is the demonstrations of this sentence, that we say that at this point, this ion has a large mass to the charge ratio, so it is less deflected. Because if it is the one which will be deflected more, will be deflected this way. Because remember that these ions are accelerating in a straight line. So it means that this magnetic field is the one that changing the directions of of movement of these ions. So this is an ion, or this the pass, the trespass, we call it a stream in chemistry or in mass spectrometer. We call that this the stream 1, for example, that this is stream 1, and then this is, let's say, stream 3. Okay, stream 3, and this is, we call it stream 2. Okay, so this is what happens. So this is highly deflected, less deflected, moderate deflected. I think that you have understood. If you have any questions, please ask in the comment section. So the first principle of working of the mass spectrometer state that the movement of ions, is detected. This now discuss about detection chamber. Is detected to the photographic plate. Detected to the photographic plate by producing a current. Okay, by producing a current, and the current depends on the number of ions produced. This current depends on the number of ions produced. So the first principle discussing about detection chamber, right? Do you see detection chamber? This is the detection chamber. So in this detection chamber, we have 3 ions. First ion, second ion, third ion. So they'll be detected by the photographic plate. And then after detection, what is going to happen? Then it will produce a current. Remember that currents, it can flow by vibrations, or yes, we call vibrations or movements of electrons, and then even ions also, they can cause an electric current to flow. So these currents depends on the number of ions produced. If you have a large number of ions produced, then the currents will be larger. And if you have a less number of ions produced, then the current will be smaller, right? That's how the principle it is. So it means that the main concept here is, remember that here we use, it means that here the chemists used to have a photographic plate in order to detect these sort of ions that has been deflected by the magnetic field regions. So let us go to the fifth principle working of mass spectrometer. Okay, the fifth principle working of mass spectrometer. And then generalize and see the applications. Remember, the concept of mass spectrometer is broad in chemistry. You can study it as well as you can. You can go in different books. Okay. The result is recorded. Now we are discussing about the results. The result is recorded. We are discussing about what? Recording chamber is recorded in a graphical manner. This is a fantastic principle. In graphical manner. Not in tabular manner, but the results will be recorded in graphical manner. Since the mass spectrometer, why? Since the mass spectrometer has been calibrated to give both mass and the intensity. Mass and intensity
intensity in 2 dimension. 2 dimension. I will explain in detail about this. The first principle right now is discussing about, because here we have an amplifier, so that's your homework. Please go and look what the functions of an amplifier in the mass spectrometer. Make sure that you read it and you find it's a main purpose. So we say that this is the chart recorder. So we call it a chart recorder because the results are given, results of the mass spectrometer are given in a graphical manner. Why? Because the mass spectrometer is being calibrated to give both mass and intensity in 2 dimensions. What does it mean? The results of the mass spectrometer will be given in a graphical order, whereby, for example, when we say about graphical manner, this is all about, we'll discuss this in detail in lecture 2, relative abundance. So relative abundance, so you say that in relative abundance, the vertical axis will be representing relative abundance, while the horizontal axis will be representing the mass to charge ratio. So if, for example, an element has 3 isotopes, then you will see lines like this one. So this is the first mass to the charge ratio, second mass to the charge ratio, and then this is the first relative abundance, second relative abundance, and then suppose that this is the third relative abundance. So this is the result of the mass spectrometer, and will be displayed in the chart recorder, or are the results that we have to see concerning about what you've been measuring, or the mass and relative abundance of what, because we say that, remember that the mass spectrometer has 3 functions. The first one is used to determine the relative molecular mass of the element, and the second functions that I told you is used to also determine the abundance, okay, and also and the third one is also to use it to make detections of the number of isotopes that are present in the element. Not every element has isotopes. Some of them they do have, and then the mass spectrometer is the one that used to make a distinction about the elements that have isotopes and elements that don't have isotopes. So you have to make sure that you understand about that. And I again remember that the mass spectrometer also it is used to measure the mass, or determines or to perform those 3 functions for the elements, and also to use it for the molecules like chlorine molecules or oxygen molecules. Not only that, but also mass spectrometer can identify those 3 parameters to the compound. Fantastic, right? So it means that the mass spectrometer is broad, depends on area of application that you're interested in. Okay, so that's all about the principle of working of the mass spectrometer I've been discussing with you. And then right now I would like just to take you and discuss in short or in brief the applications or uses of mass spectrometer. Why are we studying mass spectrometer in chemistry? Why this has been a fundamental concept to introduce to the A-level students for the first time. So just join me in a few minutes that I will mention some of the applications of mass spectrometer, and then I'll leave the homework for you, and make sure that you go through it, and will be the end of lecture 1. Don't forget to join me in lecture 2, and especially to discuss about the computations now, the problem solving of mass spectrometer, right? And then we'll be reviewing some questions that used to appear in the final exams or in different exams. So stay tuned. And remember that, stay tuned. If you have any question, please don't hesitate yourself to ask in the comment section. I will try my level best to answer. And even some other students in the world can try their level best to answer your question. So remember that you are not alone. We are together, and also you are learning this stuff with thousands of the students in Tanzania and even abroad of Tanzania. So let us go to the uses of applications. Remember that this is not a limitation that this is all about the mass spectrometer, but I've tried my level best to summarize and make sure they give you the concrete issues that you need and according to the syllabus, requirements of the syllabus. Okay? So uses or applications or uses of mass spectrometer. Mass spectrometer. What are the applications of mass spectrometer? That's the question. Okay? So the question you might be asked is, what are the applications of 40 of mass spectrometer? Why are we studying mass spectrometer? So I found 4 applications. You may find even the rest, the 2, your own 4 applications. This doesn't mean that all of these are this the end of applications of the mass spectrometer. There are some other applications. Okay? A mass spectrometer, a mass spectrometry or spectrometer, mass spectrometry can be used to identify elements from the mass number of isotopes. From the mass number of isotopes. The second application, we say that the mass spectrometry or mass spectrometer can be used to identify elements from the mass number of 40 of isotopes. That, for example, it can be given a sample of element X. You don't know what the names of that elements, and then you can use the mass spectrometer to identify which elements it is by using the number of isotopes. Okay, because you know that the number of isotopes distinguishes one element from the other element. For example, that we know that for instance, chlorine has only 2 isotopes. Okay, so so you say that mass spectrometer can be used to identify elements from the mass of the isotopes, and then we'll discuss it in detail later. The second application says that a mass spectrometer through mass spectrometry, which I will teach you, through mass spectrum, I'll teach you in lecture 2 what the means of mass spectrum can be used. This is the fundamental applications of 40 of mass spectrometer for A-level students. Can be used to calculate the relative atomic mass of the element. That the second applications or of the elements of an element. The third applications, we say that the mass spectrometer through the mass spectrums can be used to calculate the relative atomic mass, RAM, of the element. And I will teach you in lecture 2 how we use this mass spectrometer to do that. Again, mass spectrometer can be used to determine the relative molecular mass of a compound. The mass spectrometer, this mass spectrometer can be used to determine the relative molecular mass of the compound. Okay. Then the first application the first applications of mass spectrometer is this. The first application, we say that the mass spectrometer, so raw mass spectrum again, which I will teach you, is used or can be used to find the relative abundance of isotopes. Relative abundance of the isotopes. The specialized use of mass spectrometer to determine the relative abundance of isotopes is given, or in a given sample, is known as isotope ratio mass spectrometry. Okay? Isotope mass spectrometry. So we said the mass spectrometers through the mass spectrums can be used to find the relative abundance of the isotopes. What does it mean? This means that when we have the results of mass spectrometer, this, remember that I told that it represents relative abundance, and then this is mass to the charge ratio. So, but the mass spectrometer also through the mass spectrum, this is what we call the mass spectrum. For example, we have two isotopes, so isotope 1, isotope 2, can be used to find the relative abundance of 40 of the isotopes. So, and then so we learn in lecture 2 in details about relative abundance and this mass to the charge ratio. I would like just to say that let me just leave the homework for you, okay, the homework that you have to do before lecture 2, and this the question that, okay, explain briefly the meaning of the word mass to isotope ratio mass spectrometry. Isotope ratio mass spectrometry, in abbreviation called IRMS. This is the homework, and then make sure that you do this homework, and in case that you find some troubles, join me in lecture 2 when I will be starting these corrections, but depends on the finding that I will see in the comment sections. If everything is okay, then I will move to the concept of the lecture 2. And then I would like just to say that this is the end of lecture 1. Thank you very much for watching. This is Olenjolai Tayailo Singo from Tanzania, and I would like just to thank you for joining me in lecture 1 of the atomic structure, or the main topic is called general chemistry, and the topic is the atomic structure, and then the subtopic is mass spectrometer. Make sure that you join me in the second lecture of the mass spectrometer when we're doing the computations and learn a lot about the results of the mass spectrometer. Okay, thank you very much again and again. I would like just to ask you that make sure that you subscribe onto this channel, and then make sure that you share with your colleagues, and ask any questions in the comment sections as well as you can. But make sure that you go through this material, and before you go before you go to lecture 2, lecture 3, lecture 4, make sure that you start from the beginning. Thank you very much. See you in the next lecture. May God bless you. I love you.